students, welcome for our lecture series on agrochemicals and pest control. Today in this episode, the topic that we are going to talk about is pyrethroids and other natural pesticides. Pyrethroid insecticides are a special chemical class of active ingredients found in many of the modern insecticides found on store shelves and used by pest management professionals. The name pyrethroid means pyrethrum-like and refers to the origin of this class of pesticides. Pyrethroids became popular as consumer insecticides in the 1990s as replacements for older pesticides like diazinon and dustbin that were phased out for environmental and human health reasons. The topic can be studied under the following subheadings, and they are pyrethroids, phenvalrate, fluvalinate, permethrin and deltamethrin. Under the first subheading pyrethroids, let us study the historical background of pyrethroids. The term pyrethroid is confusing to many because of its similarity to the name of the natural insecticide mixture known as pyrethrum or pyrethrins. Pyrethrum is of the oldest known insecticides and comes from the dried and crushed flower heads of two species of asters. They are Chrysanthemum cineraria folium and Chrysanthemum coccineum. Purified pyrethrum called pyrethrins has been very useful in insect control. It kills a variety of insects and mites, knocking them off plants very quickly. For this reason, and because of its relatively low toxicity to people, pyrethrins remain very popular today. Pyrethrins also have the desirable environmental characteristics that they break down quickly in the outdoor environment. Unfortunately for farmers, pyrethrum has always been expensive and natural supplies are limited and often unreliable. For this reason, pesticide chemists after World War II considered it a high priority to search for ways to synthesize pyrethrins in the lab. The result in 1949 was the first artificial pyrethrin-like insecticide called alethrin. Once chemists figured out the techniques for synthesizing this class of insecticide, many different versions were created. In the 1960s, a number of new second generation pyrethroids were patented, including tetramethrin, resmethrin, bioalethrin and phenolethrin. These new compounds were many times as toxic to insects as natural pyrethrum and still have many uses today, including household insecticides. Since the 1960s, further advances in synthesis have created new useful insecticides that resemble the original pyrethrin molecules less and less. These new pyrethroid insecticides have become more toxic to insects and last longer in the environment than the early compounds. Now, let us concentrate on characteristics of pyrethroids. Not all pesticides in the same class are equally toxic or equally effective the same pests. Nevertheless, most pyrethroid insecticides share the same characteristics like low in toxicity to mammals and birds,
high in toxicity to fish if applied directly to water,
require low doses to kill insects, fast acting, especially effective against chewing insects, though many pyrethroid insecticides can be absorbed by the insect pest when it merely walks over the dry residue. They bind tightly to soil and organic matter and dissolve very poorly in water. Regarding the toxicity of pyrethroids,
pyrethroids are one of the least acutely toxic insecticides to mammals because they are quickly deactivated
by metabolic processes. Toxicity by inhalation and dermal absorption is low. Sensitization sometimes occur in some individuals after a single exposure, which causes either as asthmatic condition or a skin rash or inflammation. After the initial exposure to the sensitizing agent, the sensitized individual responds to a dose smaller than the initial dose. Symptoms are more common with exposure to the pyrethroids whose structures include cyanogroups. The second subheading is phenvalrate.
Phenvalrate is a non-leaching, non-volatile pyrethroid insecticide similar to permethrin, though much more degradable.
It is moderately toxic to mammals and is composed of 4 isomers that all have different insecticidal activities. Phenvalrate is registered for use on a wide array of crops including cotton, soybeans, corn, vegetables, apples, peaches, pears and nuts, as well as termiticide and insect repellent. Phenvalrate was first formulated for agriculture use in 1974, but was approved as a termiticide in 1987 as an alternative to the voluntarily cancelled cyclodine termiticides. During the last 1980s, phenvalrate received national press coverage due to over 200 dog and cat poisonings, including 26 deaths following the use of Blackade TM, a product containing phenvalrate in combination with DEET, a common insect repellent. EPA classifies phenvalrate products as toxicity class 2 and include the word warning on all product labels. The half-life of phenvalrate ranges from 15 days to 3 months in soil, 21 days in water and 2 to 4 weeks on vegetation. Phenvalrate is considered to be moderately toxic. Symptoms of poisoning through direct contact include dizziness and itching, blurred vision, tightness in the chest and convulsions.
Phenvalrate is a strong eye irritant and a suspected endocrine disruptor.
Studies have found that immediate application of vitamin E to exposed areas can lessen the painful effects. Phenvalrate is extremely toxic to bees and fish and is slightly toxic to birds. Coming to chemical description of phenvalrate. Phenvalrate is a yellow-brown viscous liquid that is practically soluble in water. It is stable to moderate heat and light and is rapidly hydrolyzed in basic environments above pH 8. Coming to uses, phenvalrate is a contact and systemic pyrethroid insecticide that is used to control insects on numerous leaves and fruits, on feed and cotton production, to control flies and ticks for livestock and in stables. Coming to health effects of phenylrate. Phenylrate is moderately toxic to mammals. Based on phenylrate similarities with deltamethrin, toxicity is probably due to effects on both peripheral and central nervous system caused by interference with sodium ion permeability in stimulated nerve membranes. The next kind of pyrethroid is fluvalinate. Fluvalinate is a synthetic pyrethroid which is used as a broad spectrum insecticide against moths, beetles and other insect pests on cotton, cereal, grape, potato, fruit tree, vegetable and plantation crops. It is available in emulsifiable concentrates, suspensions and flowable formulations. Coming to formulation, it is available in emulsifiable concentrates, suspensions and flowable formulations. Next is toxicological effects. Under that, acute toxicity. Fluvalinate is a moderately toxic material. It is moderately irritating to the eye and it is a mild skin irritant. This synthetic pyrethroid does not cause allergic skin reactions. Some formulated products can cause skin irritation and are corrosive to the eyes. Workers exposed to fluvalinate have reported coughing, sneezing, throat irritation, itching or burning sensations on the arms or face with or without a rash, headache and nausea. Environmental fate of fluvalinate falls under two categories, that is breakdown of chemicals in soil and groundwater and breakdown of chemical in surface water. Coming to the first one, breakdown of chemical in soil and groundwater. Fluvalinate is nearly insoluble in water and it has a strong tendency to bind to soil particles. It is therefore unlikely to contaminate groundwater. However, metabolites of fluvalinate may leach. Applications of less than 0.1 pounds of active ingredient per acre will decrease the potential for groundwater contamination. Its soil half-life is 30 days. In sandy loam, sandy clay and clay soil, fluvalinate degrades under aerobic conditions with half-life of 4 to 8 days. Under anaerobic conditions in sandy loam, its half-life is 15 days. Fluvalinate is stable to hydrolysis under normal environmental temperatures and pH. Photodegradation of fluvalinate does not occur on soil. Coming to breakdown of chemical in surface water. In aqueous solution, fluvalinate is subject to photodegradation with a half-life of 0.6 to 1 days. Photodegradation yields anilino acid and 3-phenoxybenzoic acid. In pond waters and in laboratory degradation studies, pyrethroid concentrations decrease rapidly due to sorption to sediment, suspended particles and plants. Microbial and photodegradation also occur. Now we shall move on to permethrin. Permethrin is an insecticide in the pyrethroid family. It is used in a number of ways to control insects. Products containing permethrin may be used in public health mosquito control program. They may be used on food and feed crops, on ornamental lawns, on livestock and pets, and on clothing. Permethrin may also be used in places where food is handled, such as restaurants. Permethrin was first registered with the United States Environmental Protection Agency in 1979 and was re-registered in 2006. Products containing permethrin may be liquids, powders, dusts, aerosol solutions, sprays, and treated clothing. Permethrin is used in cattle ear tags and flea collars or in spot-on treatments for dogs. There are currently more than 1,400 registered products containing this permethrin. Some products are used to treat scabies and head lice on people. Coming to the uses of permethrin, permethrin is registered for use in numerous food crops, livestock and livestock housing, modes of transportation, buildings, public health mosquito abatement programs, and numerous residential use sites, including use in outdoor and indoor spaces, pets, and clothing. According to agency data, approximately 2 million pounds of permethrin are applied annually to agricultural, residential, and public health uses sites. The majority of permethrin, over 70%, is used in non-agricultural settings, 55% is applied by professionals, 41% is applied by homeowners on residential areas, and 4% is applied on mosquito abatement areas. Permethrin is a restricted use pesticide for crop and wide area applications due to high toxicity to aquatic organisms, except for wide area mosquito adulticide use. It is a general use pesticide for residential and industrial applications. Coming to health effects, similar to other pyrethroids, permethrin alters nerve function by modifying the normal biochemistry and physiology of nerve membrane sodium channels. However, EPA is not currently following a cumulative risk approach based on a common mechanism of toxicity for the pyrethroids. Although all pyrethroids interact with sodium channels, there are multiple types of sodium channels, and it is currently unknown whether the pyrethroids have similar effects on all channels. There is ongoing research by the EPA's Office of Research and Development and pyrethroid registrants to evaluate the differential biochemical and physiological actions of pyrethroids in mammals. Additionally, the agency classified permethrin as likely to be carcinogenic to humans by the oral route. This classification was based on two reproducible benign tumor types in the mouse, equivocal evidence of carcinogenicity in long Ivan rats, and supporting structural activity relationship information. Now we shall move on to deltamethrin. Deltamethrin is an insecticide belonging to the pyrethroid family. Deltamethrin is used outdoors on lawns, ornamental gardens, golf courses, and indoors as a spot or crack and corrosive treatment. In its purest form, deltamethrin is colorless or white to light beige crystals that have no odor. Deltamethrin is in a variety of products used to kill a wide range of insects. Deltamethrin can be formulated in insecticide products as aerosols, sprays, dusts, granules and wettable powders. The illegal unregistered product known as Chinese chalk or miraculous chalk often contains deltamethrin as the active ingredients. Chinese chalk or miraculous chalk and products like them are not registered for use, and illegal products such as these should be avoided at all times. Coming to uses of deltamethrin. Deltamethrin is a pyrethroid, an insecticide used in various agricultural, home and landscaping settings. Unlike the related pyrethrins, however, pyrethroids contain higher levels of toxicity, making them much more effective against insects. At the same time, pyrethroids can pose risks to mammals and the ecosystem as a whole as they remain longer in the air, soil and water. Deltamethrin has historically been used for a variety of purposes, including vector control for insects such as the mosquito and the associated public health threats they pose. The chemical's primary functions, however, remains to be its use in agriculture and landscaping. For the latter, these applications include areas such as golf courses, park fields, home gardens and lawns, and even at times indoors. Its applications are equally diverse in agriculture. Deltamethrin is the active compound in a number of commercial insecticides such as butoflin, sizzlin and crackdown. It is mostly used for growing cotton, which in 1987 accounted for 45% of the chemical's total usage. It is also applied to commercial crops such as corn, coffee, hops, artichokes and various fruits. For the latter category, the application of deltamethrin controls the populations of insects such as apple and pear suckers, plume fruit moths, various caterpillars and aphids. For vegetables, the chemical's primary targets are aphids, mealybugs and whiteflies. The application of this product usually takes the form of sprays, wettable powders or granules. As of 1996, deltamethrin has not been found to be incompatible with other insecticides and fungicides, making its use widespread and popular, especially in conjunction with other chemical products. Coming to health effects. Human exposure to deltamethrin can occur through inhalation, ingestion and the dermal roots of eye and skin contact. Each of these pathways can possibly lead to acute health effects. Both the World Health Organization and the United States Environmental Protection Agency list deltamethrin as moderately hazardous, with the WHO labeling the compound as a type 2 acute hazard. Laboratory studies on mammals confirm this characteristic. Acute doses of deltamethrin have caused breathing syndromes, convulsions and salivation in rodents. The acute effects of deltamethrin exposure on humans include convulsions, ataxia, dermatitis, diarrhea, tremors and vomiting. Allergic reactions to the compound through skin exposure are also common among agricultural workers. It is also listed as an endocrine disruptor by the EPA. So now it's time to conclude our session. To conclude, I can say that the growing population has increased the demand for food supply, which in turn has increased the usage of insecticides and pesticides to protect the precious food source. This indiscriminate usage of pyrethroids has led to severe pollution which should be checked. New analytical techniques have to be developed to detect pyrethroids in the aquatic system. Biodegradation is a practical approach to reduce pyrethroid toxicity in the environment, and other approaches like the application of esterases to reduce pyrethroids toxicity can be seriously considered. So students, I hope you got some information about pyrethroids and other pesticides in this episode. Thank you so much for watching this session. Hope we will meet in the future episodes. Until then, take good care of yourself. Thank you.